Okay, now for what we have in problem number 8, we're now looking at the integral of e to the 3x times the cosine of 4x dx. And for what we have in the setup, we can set u equal to e to the 3x and dv equal to the cosine of 4x dx. And looking at what we have in the expressions, again we have for the differential u goes to du, and for the differential of e to the 3x we have the derivative of e to the 3x, which would be 3 times e to the 3x. Thus we have the differential at 3e to the 3x dx. And for the antiderivative of the cosine of 4x dx, that is going to be 1/4 of the sine of 4x. And in carrying out what we have for the integration by parts, we have for u times v, okay, we're going to have 1/4 of e to the 3x times the sine of 4x. Okay, and then we have minus the integral of v times du, and what I'm going to do is I'm going to leave the integral inside the integrand, or namely the fraction inside the integrand. We have 3 times 1/4 is going to be at 3/4. Then we have e to the 3x times the sine of 4x dx. Okay, and so we have with repeating integration by parts. Okay, now we're going to be looking at distribution of subtraction, but inside what we have for the integral, we have the next phase. We have u is equal to 3/4 of e to the 3x, and now we have dv is equal to the sine of 4x dx. And in looking at what we have with the differential, okay, u goes to du, and as for 3/4 e to the 3x, okay, we have 9/4 of e to the 3x dx. And as for the antiderivative of the sine of 4x, this will be at negative 1/4 of the cosine of 4x. And so in carrying out what we have, again, the first antiderivative is 1/4 of e to the 3x times the sine of 4x. And then we have distributing subtraction. Okay, we have over u times v. So we have 3/4 times negative 1/4. This will be a negative 3/16 times e to the 3x times the cosine of 4x. And then we have minus the integral of v times du. So we have for subtracting the integral of v times du, okay, what is going to happen here is that for v times du we have negative 9/16 of e to the 3x times the cosine of 4x dx. And looking at our numbers, okay, so we have within the brackets, you have positive 9/16, and as we look at the distribution, okay, so again we have 1/4 of e to the 3x times the sine of 4x, and this time we have plus 3/16 of e to the 3x times the cosine of 4x. And subtraction over addition, we have minus 9/16 times the integral of e to the 3x times the cosine of 4x dx. Okay, and if you notice, okay, we have the integral of e to the 3x cosine of 4x dx all over again. And so we can map together our terms. So we have in the setup, again just reestablishing, we have the integral of e to the 3x cosine of 4x dx equal to 1/4 of e to the 3x times the sine of 4x plus 3/16 e to the 3x cosine of 4x minus 9/16 of the integral of e to the 3x cosine of 4x dx. Okay, and so we have like integral terms, and so what we can do is that we can add 9/16 of the integral to both ends. Okay, so at least get this particular portion to cancel out. And as for combining the like integral terms together, okay, we have the coefficients going to be 1 plus 9/16, okay, which would be 25/16 of the integral of e to the 3x times the cosine of 4x dx equal to 1/4 of e to the 3x sine of 4x plus 3/16 e to the 3x cosine of 4x. And as you look at dividing by 25/16 or multiplying by 16/25, okay, we're going to have for the final answer, it is going to follow that for e to the 3x cosine of 4x dx. Okay, its integral is going to be equal to 4/25 of e to the 3x times the sine of 4x plus 3/25 of e to the 3x times the cosine of 4x followed by the constant. And so that will be the final answer.